Hey everybody, this is Larry. This is me going with Cube 4 of the bi-weekly contest 90 next grader element 4. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one I kind of messed up a lot, as you can see. My timing, I spent over an hour on this one. I think I was just to kind of give a little bit, I'd rather talk about my thought process than the algorithm just yet. And you can skip ahead anyway if you really want to. But the reason is because I think these are me trying to, figure out the lesson that I could be better about next time. I think one thing that, I always say, or say a lot anyway, is that sometimes, you're given a problem in a certain direction, like going from left to right or right to left. Sometimes it's important to kind of think the other way, right? Going like the other, and then see if you can exploit something there. And I think for this one, I think I got stuck too much in that thinking a little bit instead of I think I got I the first thing I did was I reversed the input, and I think as a result of that, and reversed the answer. And as a result of that, I think I got stuck thinking in reverse, if you will, and not thinking about it forward. I'm going to go over my solution, and then I'm going to try to solve it forward with some hints, of course, because in the process of recording this video, I did some research, but we'll do it live, and we'll see what happens. So please forgive me if it's not so smooth. But the core idea about this problem is actually not that hard. Said the guy who took really long to do it, but the idea is that I have a two-pass solution. And this is a linear time solution, so I didn't have to worry about running time. But the idea is that, okay, let's say we have this as an input, and also just the way that I did it, I reversed it, right? So let's reverse it real quick. So then we are going from left to right. So then now we have to get for each number we have to get the previous second grader, right? And the idea here now is actually get the previous greatest. Let me actually do this in Paint. I think this is actually easier to draw than whatever. So let's say we have, what was it, 69042. We could add more random numbers later. But the idea is that, okay, let's say we want to get the previous greater number, right? So then this looks to nothing. This also goes to nothing. And then 0 is going to be 9, and so forth. And then 4 is also going to be 9, and then the 2 is going to be 4, right? The idea that I had was that, looking at these pointers, just do the math on the fake numbers by pointing into it, right? What I mean by that is that now we can reconstruct an array where the 6 and the 9 points to nothing, so we could skip it for now. So let's say we have 6 and a 9, and then the 0, what happens, right? Well, now the 0, did I go the wrong way? No, I think it's right. Will now go here. And we maybe call it 0 prime. And then the idea here is then, now in this new location, what is the previous number, right? So let me also draw it out real quick. Maybe let me put 0 here so I have more space. Right, and then the idea here is that, okay, now for 0 prime, what is the answer? Well, just 6, right? And then for 4, we go, the next biggest is also 9, so that we also put here. And then what's the previous biggest, right? Also the 6. And then the 2, also the same thing. Well, here we just go here, so we have a 2 prime. Also, this is a 4 prime. 2 prime, what is the previous number? 9, right? So that's basically the idea, is that I do a two-pass system of trying to figure out what the what the previous bigger number is, and then now insert it in a way such that we look at the other previous number. So then you kind of almost like, maybe another way of thinking about it is just like bubbling up a little bit and then bubbling up again. So that's basically the way that I would think about it. Or that's the way that I did think about it near the end, and kind of got the solution. So again, I did the reversal. I set the answer to order -1 just by default. We have a stack, and here is just basically try to process all the numbers that are, so now we're going from left to right. Here are the list of the quote unquote, I want to say imaginary numbers, but that's probably confusing, but all the copied numbers, say, right? So then here we put all the numbers on the list. We find and this part is just, greatest next greater. It's, I don't know if that's the problem name, but one of the next greater element ones where you do the stack thing. Not gonna lie, I assume that you know that solution, and with that, then watch my previous video, because this is just about finding the invariance, but it's also going to be harder if you don't have that basis, and I don't really have the energy today to kind of go over that part, but I do have video for it, right? So definitely check that out first on one of them. Because this is the fourth next greater element. I don't know which one is the standard one off my head without research, so my bad. But yeah, so then we put it into the thing where C, we keep track of the index, and then we also just keep track of the other index as well. But this stack, the top of the stack, is the index of the element of the last the last greater, right? Of course we say last greater or previous greater because I will reverse it, just to be clear. And then the second time is just we do it from left to right again. Now basically whenever we get one of the prime numbers, we actually update the result. That's basically the idea, and you can do that in and everything is in linear time in total. So this is linear time, linear space, because each element has at most one element, and each number can at most be popped and pushed twice, right? Once from the first stack and oh jeez. Each number can only be pushed and popped twice. First time on this stack, and then the second time on the second stack. So yeah, linear time, linear space. So I'm happy with the solution, to be honest, but wasn't happy with the time. So when I did, as I said earlier in the video, did I take off the, okay, just to make sure I didn't have the painting thing still on. What I should have done, or what I saw people did, is just going from left to right straight. So I was trying to use this like stack thing. I was also do sort list, but in a different way. But yeah, but the idea that we can do another way, and we're going to code this live. So hopefully you have the code. Here's the code. Maybe I'll make it slightly smaller so that you can see the entire code. So this is the code if you want to check it out. But yeah, the second one is basically parsing from left to right. You just keep track of the numbers that are, you basically keep track of the numbers that have passed one bigger number, right? Meaning that, let's say, let's look at the example again, right? That means that for let's say we have a bag, we just have a bag of nothing, and then a second bag, I don't know, right? First you put 2, that's fine, and then so you put the 2 in the bag, and then when you get to the 4, you're like, okay, well, 4 is bigger than what numbers? 4 is bigger than 2, right? So because 4 is bigger than 2, we put it in the 2 bag, and then at the very end we put in the 4 bag. And then now next we do 0, right? So 0, okay, it still is not bigger than any number. We just put it in the bag, I guess. And then next 9. So 9 is bigger than both the numbers. So then we put them both in this bag. And also, the 2 is now, you could say, graduated, right? So now 2 is here and 2 points to the 9. We can do the math a little bit, but we can talk about implementation, but that's basically the idea. And then the next number is 6. So 6 does not unbag anything here, but it does unbag these two things. So it's almost like a 2-pass type thing, right? So now 4 and 0 is equal to 6. That's basically the idea behind the 2-bag thing. And if you kind of, already kind of, if you, thought about it, what is a good data structure for bag, right? Well, of course, if this is just an array, as I kind of showed it here, but not really, it's going to be linear time every query, and that's going to be n squared, and that's going to be really sad. But keeping in mind that you only what is your actual query, right? Your query for both bag and second bag is just taking the number, and then every number under it, you move it to the second bag or move it to the answer, right? So if that's the case, then that's pretty much it. We can use a heap, we can use a sorted list. There are a couple of things you can do, and so let's do it. Let me try it out, and I really should have gotten this one this way. I think I was just so stuck on the reversal thing that I don't know. Sometimes these things, you get stuck in a mindset and stuck in a moment that you can't get out of. Something like this, right? So yeah, so for x in num, say, and we have do we want to do heap or sorted list? Doesn't really matter, right? So we have a heap 1, we have heap 2, right? And then first, and then answer, let's just say answer is equal to -1 times n. N is equal to length of nums. Of course, this has to be before. Yeah. And then, so, yeah, okay. So then first we take it, because we don't want to propagate from bag all the way through, we'll take it from the second bag first. So, yeah. Yeah. So then first we well, we don't want to push yet. Hang on. Sorry. We want to pop. That's why I was confused. So we maybe that's not even right. So so while length of heap 2 is greater than 0 and heap 2 of 0 is less than x, right? Is it less than or equal to? If it's equal to, then you don't move to bag, right? So okay. Also index. Right. Well, if this is the case, we take it out of the bag, and then what do? Right. So so the current x and then the previous y. Oh, this is a smaller number maybe, right? And then now we put answer of p index is equal to x, right? Because the x is what gets rid of this bag. And then now, while length of heap 1, so we do the same thing, but for heap 1, but instead of freeing it, we just push it, right, to heap 2. And then finally, we push this into heap 1. I think this is mostly right. So yeah, and then now at the end we return answer. Heap Q? Did I misspell heap Q? Always think that this is a real library, but oh whoops, this is this up 0. Heap, I've been misspelling a lot of stuff. Heap PP pop. Okay, so that looks good. Let's give it a submit. Cool. Yeah, so I definitely apparently should have done it this way. This would have, I don't know. I just kind of get, and that's the thing, right? Sometimes you get stuck in one way of thinking, and I didn't even, not gonna lie, like, and you can watch the video. I really did not think about how to. I just never thought about going forward. That's basically the answer. I don't know why. Maybe this is just one of those days. But yeah. And you could as you can see, this is going to be O of log n for each query, for each number, and this is O of n, so this is going to be O of n log n time. And for space, this is going to be O of n, because that's how heap works. Yeah, that's pretty much all I have. So let me know what you think. Yeah, let me know what you think. You could watch me solve it live during the contest next, but keeping in mind that I spent a lot of time doing nothing, and I was actually, just to be clear, or just add some flavor, I actually tried to look up segment tree and stuff like that, but I couldn't really figure out how to do it that way either. I'm not that strong in segment trees, to be honest. So yeah, but I tried a lot of these different things with 2 stacks and stuff like that, but I think I just didn't have to, like it's kind of sometimes one trap that you can fall into is a pattern driven one where you're thinking of just like, hey, this is a data structure, how do I get to it? But once you have the visualization and how to think about it, the code really comes out by itself. As you can see, this is like, and I actually said like, oh, I bet you the good code is like 10 lines of code, and this is basically it, right? So yeah, anyway, you could watch me solve it live during contest next. Let's go submit. Hopefully no silly mistakes. Okay, good. Whew. Four is 9 is okay. How to do the next number 1? So 6. Oh, so we can't just sort it. So okay, 6 here, then you pass the 9, and for 0 we go, okay, 0, 9. Okay, how do we do it? Well, we see the 9, which is not good. Do we just do it twice? Run it twice? I think you just run it twice, but is that true? So we do the biggest number. If it's bigger, what happens? Bigger than you should do. It's not the second biggest though. It's the number that is. It's not the second biggest. Is that? It's the number that's the second biggest, not the second largest. Because let's say we have a -1 on the left, then this is 0. So we can't even forward this in a mono, whatever. How am I doing anyway? Doing okay. Hope you finished already. I go from 4. Huh. Don't know how to do this one. A lot of people's kind it though. Let's say we do a binary search. And we see, no, you can't do a binary search like that. Okay, no, that's it. It's 6 way fine, but 4. Can't get rid of the 0. That's the problem. And the 2. Well, now we can get rid of the 6. Okay, so what is the thing here? Right? We can't get rid of the 0, but at the 4 we can get rid of the 6 because... No, that's not true, because if I had a 5, then this is a 6. The answer is a 6, right? So, when can we get rid of this 6? Can get rid of this 6. Can I sort? Is there something just like dumb like that? Huh. A lot of people getting it, but so if this was smaller than the 0, then we need to, and later as well. Is there like a still can I just I'll do this one. Okay. Can I eliminate more things at least? Because, well, no, because again, if this was 5 and 4 and 0. So what are all the possible answers, right, for this one? Let's say this is possible answers is if this is just like straight up negative, then it'll be 0. It can be 9 if it's between whatever, and then if it's 0 to, if this is negative, And just 9 if it's from, I don't know, 0 to 3 or something like that, or 1 to 3, or maybe 1 to 4, doesn't matter. And then 5 to, I guess just 5, then the answer is 6. Right? Still, can I represent that? And also keeping in mind, we have to keep track of the 4. I think 4 or 5 is the answer, but so basically we have this thing, right? So we have this range, and then we just keep on dividing it. Is that right? So then, okay, let's start from scratch. So with 6, nothing happens. 9. Well, now with 9, we have a space that is 0 to 5 is going to be 6. Okay, and then yeah, and then 6 and up it's going to be -1, right? And then we add a 0. What does that mean? We add a 0, we actually add the number 6 or number 9 into the thing. First we process the 9, and then the 9 means that, what does processing the 9 means in this range? That means that everything under 9 is going to be 6. I don't know if I know how to do this one. And then, yeah. And then next we process the 0. We have a 4, but we process the 0. And then that means that we process the 0. That means that everything's smaller than 0 or 0. I guess 0 to 9 is still 6 then. And then we have 6 as the answer, and then now we process the 4, right? How do we process the 4? I don't remember. We process the 4. That means that, well, now means that 4 to 9 is some answer, and which is the previous one, which is 6, and then 0 to 3 is going to be 9. How do I even get 9 in this case? Oh, that's just the previous range? Is that true always? And then now we process the 2, say. Must be a similar problem, is it? Similar answer, right? So 0 to 1, 2 to 3. 2 to 3 is going to be 4, and 0 to 1 is going to, no, wait. 0 to 1 is going to be 4. 2 to 3 is going to be 9 still. That's the way to do it, but doesn't feel easy to do. So we can, do the APO guide already. Maybe that's the right way. Okay, fine. Basically, we first look up the number. X. And then Okay, and then SF index. So now we have so then we have the second element. And then now we actually what we want so that we can what we want is actually something like that with infinity. So if it's the same, then we go to the previous one. Is that true? Nope. So let's do bisect. Okay. And then here now we take this is always true, and now we have yeah, okay, and then now we split it into from this number into SL of x minus 1 this number or now? Now is the previous. What am I doing now? Okay, let's try again. So we start at 6. Six doesn't do anything, and then now we get the 9, fine, and then we process the 6. So then 0 to 9, it's going to be 6. Or 0 to 6, it's going to, or 0 to 5, it's going to be 6. So maybe I am one behind. So that means that when we process the 6, okay, fine, we do a search, we found nothing, and then process the 9, and then that means that we process the 6, we go, okay, then this happens. And then now we process the 9. So we have to do like one behind kind of thing. No, I don't want to. Okay, so then if previous is not -1, otherwise previous is equal to x. And now so we want to remove now then we process the previous, so okay, fine. Okay, and then now we remove it. Okay, what's up next? So let's say that we set the 0, we set the answer to 6, and then we process the 9. And then process the 9 means that 9 to infinity is -1, and 6 to 9, it's gonna be also -1. So what does processing 9 means? Oh my. Well, no, we process the 0. Process the 0, which means that in the future this is wrong. So what am I doing? Okay, so let's initially 0 to -1, and then we process to 6. Nothing happens per se, or we don't process to 6 yet. We process to 9, or we're up to 9. We process to 6, and then the 6 would be 0 to 9. No, 0 to 6 is going to be 6, right? No, 0 to 5 is going to be 6, and then 6 to infinity is going to be -1, and then we process to 9. After the 0, we get the score, and after we process to 9, which means that we process to 9. That's what we're doing with 6. So processing the 0 means that the 9 previously, if it's greater than 9, then it's infinity, right? Let's be clear there. Let's just do it separately. From 6 to 9 is also -1. Okay, that's fine. Or 8, whatever. And then 0 to 6 or 0 to 5, it's going to be 6. Okay, maybe that's fine. Maybe I just underrepresented. And then now we have the 4, so we process. So what's after the 4? 4, we process the 0, which is why it's a little bit weird. But then we have negative infinity, but that's fine too. Okay, and then process the 0, which looks exactly the same, and then 4, we go 0 to 4, we have 6, 4 to 5, we also have 6. Is that true? And then 6 to 8, this is technically just 5, I think. Also, that's not true, this is 9. So we don't even know how to get the 9 from. Huh. I don't know that this is the right way to do it. Huh. A lot of people got it though, so good for them. I could do some range thing, but I don't think this is the right way now that I think I just messed up by going too fast. Yeah, this is not great. A lot of people got pretty fast actually. Because it's not the second greatest element, it's the next. That's the hard part. Okay. Is it a stack thing? Can I do it? Because here 0 is smaller, then we throw it away. 4, we go, okay. The next great element is 9, that's fine. Then now we have to care about the 6. How do we care about the 6? Right. Because we throw away this, I mean, if this was like a, I don't know, like a 4, we can't really throw it away, or like a 5, we cannot throw it away. And it's not the next element that's greater than that one, it's just greater than 4. So we have to keep track of everything, right? Pretty much. I just don't know how to do it. I have 1 hour, but I'm so tired. Can I keep it in a sorted list in a different way? It was one like a weird KD tree, but that's really intense. Can I do it in a segment tree? I don't know enough about segment trees. I'm just looking up segment tree. It's been a while. Did I do it in segment tree? Like a segment tree, and then you know there's a more segment tree. No, that's silly, right? I guess today's just not my morning. I don't know how to do this one, and people did it pretty quickly. Also, this is not true. They're all 049. Whatever, 5 maybe. It's all 6. Right? That means that I have to do the. I don't know how to process this though, to be honest. Like, even if this is the answer, I don't know how to process it quite well. So we have 6. Numbers is pretty big, so then we can normalize it. I think that's not a big deal. If we normalize, can we do it better? I don't think so. Quite the same. Reindex. Yeah, maybe it's just so bad these days. There goes my whatever. it a stack? I feel like it is a stack thing, but I don't know how to do it. So we get the next biggest number. Can we use that? Like from 4, we find 9. Okay, fine. But can we use that to do it again? Can we just use 2 stack? Is that really the answer? I'm just overthinking it, and that was my first instinct. I don't know. Let's go. I'm out of options, I guess. Okay. And then so what happens? It's 4. I don't know, but okay. So the 4 is going to be a 6 because the second. But again, I don't know how to do it. Because if you have a 7, then it's maybe that's fine. But then now you get rid of the. Like the thing is. The thing is that there's different numbers, right? Because if you have like, I don't know, then in this case, if you have an x, and then x could literally like give you every number. So I don't think a stack is good enough, right? I don't get it. Wow, a lot of people in my chat is getting it, but apparently I am just. Today's I'm not my thinking. It's not right. Just looking at more. I guess this is an example, though it's not. Whatever. But in this case, so you have to do some sort of binary search, and there's no way to go around it. I don't get it. My brain has not been good lately. A lot of you got it. Maybe this is just one of those days. Because here, when we binary search, what will we binary search on? Also, what is this answer again? So if it is 0 to 1, it's going to be 4. If this is 2 to 4, maybe it's going to be 9. If it's 5 to just 5, it's going to be 6. If it's 6 to 9, it's going to be infinity or -1, and 9 to infinity is going to be -1. This is so weird. Maybe I need to store more info. Maybe that's it. Maybe from 0. Okay, let's try again. So 0 infinity, -1, -1, -1, say, and then 0 to 6, we process the 6. So 0 to 6, we have -1. We have 6 -1, say, I don't know if this is true. And then we have 6 to, okay, and then 6 to infinity, y -1, -1. And then now we have to process the 9. So that means that 0 to 6, it's still going to be 6 -1, right? 6 to 9, it's going to be also 9 -1, but 0 to 6. But now it update this one, right? So that's weird, right? Because 9 to infinity is going to be -1, -1, say. But then 0 to 6, it's going to need to upgrade from like to this or something like that. But if we have a 9, we're not going to binary search enough on it. Huh. Oh, I don't know. Right? So I don't know that we can do something like this easily. It's just going to be one of those problems where I see it and then I'm like, oh, this is a 5-line code or something. I don't see it. I'm just looking up seg tree again. No excuses. Just focus. A lot of people got in this one though. I don't. Maybe it's just one of those days. Maybe I also need more practice. Talk about practice. I don't get it though. How would you? Two to 4. That's a very awkward thing to do. But maybe the sorted list is the right way to go. And we're just stubborn. look up some data structures. But can we get rid of the... No, it's not the second larger one, right? That's the problem, is that if we use 2stack, let's just say we get rid of the 9, what happens? It's not just the number that's... Maybe it is. Maybe I'm just being too dumb. No, because of this case, you can't really get rid of numbers. Every number matters. So if you add, like if this is a 5, you can't get rid of these because that may be the next smallest number is like 1 or something, right? But I see can I use 2stack in a weird way? Come on, Larry. Can we skip this 5 and then do the... Let's skip one number and then... But you don't know what the number is until you do it. You can't do one or twice, can you? Larry needs more sleep. Even I solve it now, it's so slow. And I'm not even solving it now. Is there a stack? No, we can't. Keep trying to go back to stack solution, but it doesn't seem like that could be it, right? Like literally there's 3 possible solutions. Maybe this is just the right way, and I'm just being lazy about it. So we pass to 6, still -1, 6, 2. But then when we pass to 9, then 6 to 9, it's going to be -1, 9 to infinity, -1. But then 0 to 6 is going to be 9, right? No, it's going to be 6. And then now process 0, which is weird, but then, so nothing changes. Well, that's not, well, okay, yeah, nothing changes. And then process to 4. So where do we get the 9 from? Also, this is 0 to 5, but that's fine. All right, oops. Now we process the 4. 0 to 3 is going to be 9. 4 to 5 is going to be 6, just like before. And then everything else is the same. And then we process to 2, and then we get this thing. Oh, is this true? Maybe I'm off by 1 on the 4. No. Let's do it again. Okay, fine. Process to 2, so 0 to 0 to 1 is going to be 4. 2 to 3 is going to be 9. That's why. Off by 1, but so the question is, where would you get the 4 from? If you process the 2, get the previous number. Okay, fine. Is that really right? Let's give it a go. I don't know. I'm not doing anything else, right? Should always be. Okay, fine. Otherwise, and then when we process the 6, we split it up. Excuse me. Oh man. So then we process the 6. The 6 would be oops. Right, something like this, right? I don't think this is quite right yet, but just want to see what it looks like. Oh, whoops. Sure. Okay, that's not great. Also, the sense is just weird. Oh, I have to reverse it, but that's fine. Hmm. 0, 5, -1, and then oh, wait, what? Oh, whoops, this is not +1. That's why. Well, I mean, that's not the only reason why, but okay, so maybe that's okay, and then 0, 5 should be 6. Oh, we didn't update the previous one. It's okay. So 6 to 8 is actually not. This is the previous. Oh, no, this is Y. And then this is also Y. We just have to split it up. And then the something like this. Okay, I mean that's just not right still, but at least it's closer. Let's see, 681 over. Okay. Well, this is just awkward, but I think this is if. Do something about like dupes, possibly. Okay, so this is maybe better, but we lost a 9. So we did the 4, so 0, 3. Why is that still 6? Oh, but the previous is like 0 for that, so that's just weird in both cases. How do I get that to be 9? I'm definitely missing something really fundamental to this problem. Honestly, I have no idea what I'm doing. I'm just like looking up random data structures and it's not really helping. uh, hmm. I am just blanking out. I mean, this is an opportunity to learn. I think it's either that I miss something really obvious, and I mean that probably is true because a lot of people are getting it. Like I am. This is gonna be a disaster. Hmm. 20 minutes. Wow, I am really bad. Okay. I need to start practicing. I think that's it. I cannot coast on not practicing maybe anymore. But we've gotten this in like 5 minutes. So it's not like some. This is too crazy for it to be true. I think I will win this twice. Then maybe keep it up. I mean, this is just one of those days. I mean, like everything in life, you're gonna have bad days, and I'm just having a rough period lately. 18 minutes. People have done it in less, so let's focus now. What would that look like? See, maybe look a lookup table. And then, oh, I see. Huh. I see. Maybe. X. And then now we do it again. Maybe. Actually, I want to do something like, I don't think this is quite right, so. Let's do, yeah. Let's do it this way instead. Now, it's a little awkward actually, but this one or? Maybe. Mm, 13 minutes. Because I changed the frame. Something like this. 2 layers. Well, that's not good. That's something I clearly did, but append I, append V, append X. No, is this right? No, this is I. That's not great. Okay, so we know that doesn't happen, but well, this is reversed, but so 6 goes to 9, goes to D4. Seems okay. What am I doing wrong? Okay, so every number is represented, so why is it wrong? Tell me why. This looks okay. Maybe I should just put this as -1, but still the other stuff looks okay. So why is it not updating for here? And that's fair. 9, that's fair, but 3. Oh, did I do the wrong sign? Shouldn't matter though. Well, at least I should give me some answer. Oh wow, I was doing the wrong sign. Whoops. Maybe it's wrong though, but
I'm being dumb. I am very dumb.
Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Yeah, stay good, stay healthy, to good mental health, and I'll see y'all later. Bye bye.